चलो कैम्स ऑन एवरीवन. Let's start off with this. Two spheres, 2m and m, both are going with u. E is equal to 1. This is an oblique collision. If identical masses collide obliquely, one at rest and E is equal to 1, how will they move after collision? So that's more of a theoretical thing, the second one. So how do we handle oblique collisions? So an oblique collision is nothing but a head-on collision plus the perpendicular component. So this is how you do. So in this kind of problems, now step one, draw the picture just before collision. Draw the normal. In this case, it will be the line joining the center. If you look at these angles here, this distance will be 2r. So it is passing through the center. This is r. So this angle will be 30 degrees. Then resolve the velocities along the normal and perpendicular to the normal. This guy will be u sine 30. This guy will be u cos 30. Same thing. This is u. This is 30. So you can split this into two parts. Where this is going with u cos 30. This is going with u cos 30. This is u sine 30. And this is u sine 30. We know during the collision, only velocities along the normal will get affected. The perpendicular components will not change. So these components are not affected. So this is mass m and this is mass 2m. And then what you do? Then you just do it like a head-on. So this is a head-on collision. So then you will say after collision, let this go with v1, let this go with v2. Then you know the story. Conservation of momentum, 2mu cos 30 minus mu cos 30 is equal to mv1 plus 2mv2. Quotient of restitution, V2 minus V1 by U cos 30 minus of minus U cos 30. V2 is minus V1 by U1 minus U2. Solve them, you'll get V1, V2. So your final answer will be, this ball will go with V1 and it will also go with U sin 30. This ball will go with V2 and is also U sin 30. Clear? So just draw the normal before collision, resolve the velocities along the normal, perpendicular to the normal, find the velocities using head-on collision, and then add back the perpendicular components. All clear with that? So an oblique collision is simply an head-on collision plus the perpendicular component. What about the second part? If the identical masses collide obliquely, one at rest and E is equal to 1. Answer is 90 degrees, so remember that. If two identical masses collide and E is equal to 1, this component will be whatever it is, ux, and this component is uy. So after collision and masses are equal, so they can ask a statement like this, if two identical masses collide elastically, they should always exchange velocity. That is wrong. They should exchange velocities only along the normal. That is right. In a head-on collision, they will completely exchange velocities. So after collision, the picture would look like this. They will exchange the velocity. So this guy will go with ux. The perpendicular components are unaffected. This guy will go with uy. This angle will be 90 degrees. So after collision, both will deviate to an angle of 90 degrees. Happens only for this special case you're getting it. Masses should be equal. E is equal to 1. What about this thing? Let's get this. We have a rocket there, 1000 kgs. Gravity is there. UR is 400 meters per second. Gas is ejected at a rate of 50 kgs per second. Find the acceleration of the rocket at 5 seconds. Second part of the question. Find the velocity of the rocket after time t. Same thing, U relative, lambda kgs per second. If g is equal to 0, find the final velocity. That was a CT question. Let's see. So how do we handle this? So first thing, in case you forgot, whenever you have a rocket, there is something called a thrust force. Because the gas is being ejected, you generate a thrust force, which is minus U relative dm by dt. This is the formula you should know. Minus sign indicates it is opposite to the gas direction. So if you're ejecting it backward, forces forward. That's it. As long as you remember this, you will be fine. So the first question, Draw the FBD. What are the forces acting on this? We have F thrust, which is how much? 400, and dm by dt is 50. That's 4,000 into 5. That is 20,000 newtons. So the rocket is generating 20,000 newtons, and you want acceleration after 5 seconds, and you're burning fuel at a rate of 50 kgs per second. So you burned 250 kgs of fuel at t is equal to 5 seconds. 250 kgs fuel is burned. And that means you're left with 750. That is 7,500. And your acceleration. So mass is 750. You're done. So 20,000 minus 7,500 is equal to 750 acceleration. You'll get the answer from there. What about the second thing? You want to find acceleration as a function of time t? Same story. F thrust, mg, acceleration. So this guy will be ur dm by dt. So you just take the magnitude. The sign is already taken care when you kept it upward. Minus mg is equal to ma. So we get acceleration is equal to ur lambda by m, which is m minus lambda t minus g. And a is nothing but dv by dt. Integrate this. You end up with u relative ln m by m minus lambda t minus gt. Standard result, you should know this thing. If gravity is 0, then when the fuel gets over, then the answer will be ur ln total mass by final mass. That's your final speed of the rocket. Standard results. Both are standard. You should know how to handle both of them. This looks like this is an integration, but this is a very standard question. Rocket propulsion, in case you forgot. So that's the main formula there. So here the catch is mass is changing. Let's get this thing. A force 2i plus 3j plus 4k acts at the origin. Find the torque about 1, 2, 3. We have a rod on a smooth wall and a rough ground. Find minimum mu so that there's no slipping. Let's see. This is an easy one. But the first one is a very standard question, and most people goof up. Most people goof up, meaning it's a simple one. So if you remember the formula, torque is given by r bar cross f bar. What is r bar? R bar is a vector. It's not a position vector. Be careful. It is a vector from axis to the point where the force is applied. So in our scenario here, the axis is A, the force is applied at the origin F. So your R bar is AO bar, it is not OA bar. So it's minus I cap, minus 2J cap, and minus 3K cap. And then torque R cross F. Then you know how to do 3 into 3 determinant. I will leave it there. It's I, J, K. -1, -2, -3, and the force is 2, 3, 4. If you take that r as a position vector, you'll get a minus sign. So be careful with that. That's it. So there'll be two options with a plus and minus. So do people do goof up? So be careful with that. And what about this thing? Write the forces. Normal reaction, friction, second normal reaction, and mg. Take the torque about the bottommost point. If you take torque about A, that will be mg L by 2 cos theta minus N2 L sine theta is equal to 0 because it is in equilibrium. We will get N2 is equal to mg by 2 cot theta, and N2 is equal to friction, and friction is less than equal to mu N1, but N1 is nothing but mg. So cot theta by 2 is mu must be greater than equal to cot theta by 2. If the friction is less than this, the rod will slip. Clear with this? So free body diagram, forces, torque equation, solve. That's what I'm saying. This question, did you see how did I solve this? Meaning I saw the question, I kept the FBT, I started solving. It didn't take me more than a minute. Maybe I'm used to it, so maybe you can do in 1.5 minutes maximum. Like that is how it should be. Standard models should not take more than 1.5 minutes. That is assuming, meaning if you should technically speaking, these two questions you should have finished in a minute and a minute. Like, let's get this thing. We have a truck here going with an acceleration 2 meter per second square. The truck is rough 0.5, and there's a 10 kg block with 2 meter and 1 meter dimensions. Find the position of normal reaction and find the maximum acceleration for no toppling. This I bumped up the level a bit. Let's see how will you handle this. Let's see. I told you the moment someone asks you find the position of normal reaction, this is not your NLM problem. This is a rotation based one. So draw your free body diagram. Put the forces mg. Since you're standing on a truck, so I'm keeping the observer on a truck, so you will experience pseudo force. So the pseudo force is the one who's responsible for dragging it out. Friction will be backward, and let the normal reaction be somewhere here. You just keep it little to the side and let this distance be x. So you don't want it to topple. Okay. So you don't want it to topple. Fair enough. So take a torque about center of mass. Now, why am I taking about center of mass and not about any bottom point? There is a possibility, this might be skidding also, isn't it? So actually, I need more information. Is it skidding or not skidding? So because if it is not skidding, then F is not maximum. So let's see what will happen. If you take torque about the center, the pseudo force goes off, right? Then you're left with F and N. Then this would be F into what is that distance? That would be half meter. minus n into x is equal to 0. So then we have f by 2 is equal to nx. So we get x is equal to f by 2n. So if you don't want to topple, the x ka value cannot exceed 1 meter, because if you look at this distance, the green line, this thing is 1 meter. Right? So that is the condition. Now we have two cases. You're slipping, then f is maximum. Then your answer becomes mu n by 2n is less than 1. And yeah, and mu ka value is also given. If you're slipping, then and then goes off, and mu is less than equal to 2. Yeah, then it definitely topples. There's nothing you can do about it. And the second case is what? Assume there's no slipping. I think I should give you need it. Or else that pseudo force is useless actually. If it is not slipping, then it is clear f is equal to ma. And this will be ma, and to when n is nothing but mg is less than equal to 1 meter. So what do you want to find? You want to in position of n, right? So that is done actually. X ka value, you'll get it from here. And then this will be a must be less than equal to 2g. So 20 meter per second square. Clear with this? So first put a is equal to 2 and solve. That will give you the position of x. And the second thing will give you that answer. M is 10, A is 2, and this is 2 into 100. That's 0.1 meter. So the first answer is 0.1, and the second answer is acceleration must be less than 20 meter per second square. Clear with no toppling thing? Let's get these three. We have a square frame made of 4 rods, M and L, find moment of inertia. We have an half ring, M and R, find time period for small oscillations. We have a square plate about an axis 15 degrees in the edge. All these are standard questions. We have done that in the notes. Second is a good one, find time period. You guys remember the formula for time period for physical pendulum? 2 pi root over I by mgd. याद है? That's the formula for physical pendulum. Let's get all three of them. Let's see. So how to do the 82A? Now, one way, right, is you take the axis, you take this rod, and then you take this rod separately. But then the problem center of mass is here. We have to use parallax theorem. It becomes lengthy. There's a better way. First, find the moment of inertia about the center of mass directly. Now, all these four rods are symmetrical, and all these rods are making 45 degrees. And hope you remember the result. If a rod is making 45 degrees with the axis, the moment of inertia is ml square by 3 sine square theta, sine square 45. And how many of them are there? There are four of them. So that is your moment of inertia of this square frame about the center and passing in the plane. Now you want about this point A, and this distance will be L by root 2. So moment of inertia about A will be I center of mass. Now be careful when I say md square, m is the total mass, which is 4m in this case. That is one mistake people do. They take it as m. Happens in a flow. You do that, and then there you are done. That's it. That's it. So how much is this? ml square by 3 sine square 45. That is 1 by 2. That is gone. And this is 4 ml square by 2. This is 2 ml square, and that's this is 2 ml square. 8 ml square by 3. What about this half ring? I'll tell you about the square plate. I hope you remember. Anything that is passing through the center at an angle theta, right? The moment of inertia is independent of theta. ml square by 12. That's a good result to remember. That itself would be a question in the exam of bits or something. Any line passing through the axis in the plane of a square plate, it is ml square by 3. And here the most common mistake is this. People think the half diagonal is the perpendicular distance, which is not true. If you get this angle comes out to be 60 degrees. You should check out in the class notes. We have done this. And then I think I remember the answer, 11 ml square by 24, I guess. Check it out. So the perpendicular distance is not the diagonal, but something else. It's some other distance there. This is L by root 2, and this is 60. This is the perpendicular distance, which is L by root 2 sine 60. From there you get it. What about B? B is a good one. Again, most common mistake, center of the circle is not the center of mass. So if they call this O and this is your center of mass, IO is mr square, agreed, but you can't use parallax theorem from IO. So this is I center of mass plus m into, what is the distance from center of mass to here? 2r by pi. This distance will be r minus 2r by pi plus m into 2r by pi whole square, and this will be IA will be ICOM plus m into r minus 2r by pi whole square. Subtract them. From here you'll get IA. The time period formula is 2 pi root over I by mgd, where d is the distance from the center of mass to the axis, which is r minus 2r by pi. And the best thing about this question, right, if you have taken it as a mistake, right, if you have taken the center as the center of mass and solved the problem, you would have still got the answer. Meaning, it happens, but be careful. This was a 2004 JEE question, long back. So moment of inertia and the parallax is there. Let's get these three. 4. Moment of inertia is 3x square minus 2x plus 7. Find the center of I center of mass. What is the locus of all the points with the same moment of inertia? For a square plate, triangular plate about the base, what is the moment of inertia? This D is an important result. We have a cylinder, length L, mass and radius R. What is the moment of inertia about the edge of the axis? Get them. I'll give 2-3 minutes. BCD are literally the results. You should know them. You won't be able to derive them in exam like means. And D is a very important question. It has been asked multiple times in a different way though. One of the question was like this. I think it is, I don't remember, 6-7 years back. They said there is a cylinder of a constant mass, R and L are variable. So the question was like this: find the ratio of L by R if the moment of inertia is maximum. So you have to get the moment of inertia and differentiate into maximum minima. There was a question like that. That was the main question. Let's get this for, I'll give 2 minutes. Let's see. So what is the answer for this? So if you remember, center of mass has a property. The parallax theorem, IA is equal to I center of mass plus md square. So among all the parallel axes, if you see the moment of inertia of about any axis is center of mass plus something. Now, this is important. Huh? They will make a statement like this. Moment of inertia about center of mass is minimum. That's a wrong statement. Getting it? That's a wrong statement. You can actually create a system where, for example, see, if you have an axis passing through the center of mass, this is ml square by 6. I can create an axis in the plane which is not passing through the center of mass. I can still get less than that, ml square by 12 plus md square. So the statement is this: among parallel axes. So if you don't use it among parallel axes, then your statement is wrong. You can compare only between the parallel axes. Among parallel axes, moment of inertia about center of mass is minimum. So if you're just randomly comparing any two axes which are maybe perpendicular or skew lines, it doesn't work. So once you know it is minimum, you are done. Just do maximum minima. di by dx is equal to 0, x is equal to 1 by 3. Take that and put it here. You will get I center of mass. Locus of all points with the same moment of inertia, it is a circle. We are talking about axis, not points. Axes are lines. It's a circle. IC1 plus MD square, D is equidistant. What is the moment of inertia of a triangle plate? MH square by 6. Hope you remember that. It only depends on the height. It doesn't depend on the base. What about this guy? If you're talking about the edge, then the moment of inertia, you can treat this like a rod plus an ml square by 3 plus a disk about the diameter, which is mr square by 4. If you want about the center, then it is ml square by 12 plus mr square by 4. Clear with that? Let's get this thing. We have a solid sphere, mass and radius r. If h is equal to r, find a center of mass and friction and mu minimum. Find h if friction is 0. Two different questions. Where should I apply the force in if the friction is 0 on the solid sphere? They can ask a question like this also. Find the position of the force if the ball never slips. Meaning, even if you apply infinite force, the ball should not slip. So you have to find a point where f is always 0. Then it doesn't matter how much you apply. Let's see. Draw the free body diagram. So the first case, you're applying force at the top. Let the friction be backward. Now the thing is that I actually don't know the direction of the friction. You can take anything and then it is fine. Sine will take care of it. This is mg and this is normal reaction. Let the acceleration be a and let this be alpha. And see, if you're on a ground, this point A is a nice one, right? You can take torque about it. Let me ask you something here. Let's say if you have a sphere, in this case, okay, what is the acceleration of point A? Or let me ask you this thing: is the acceleration of point A zero? Or instead of saying, say, is the acceleration of the point in contact with the ground is always zero? What do you guys think? No, be careful. Huh? It's not zero. Why? If you remember, every body will have three accelerations. So we have your ACOM, we have alpha, right? And we also have omega. So this point will have a center of mass. This is translation. And most people think, you get A is equal to R alpha. You think this is derived from circular motion. No, that's a blunder. It's not. The no slipping condition is not A is equal to R alpha. At this point, we have A tangential backward that becomes R alpha. And we also have a centripetal, which is omega square R. Remember? Every point will have three accelerations. So after some time, you will have some omega. So centripetal is not zero. So what is no slipping condition exactly then? No slipping condition is A center of mass minus A tangential is equal to A ground. You're touching the ground. And A ground is zero and A tangential is R alpha. You're getting A tangential is R alpha. You're getting it? That came from circular motion. A center of mass is not R alpha. That didn't come from circular motion. A com is equal to R alpha. That's your no slipping condition. You're getting it? So this point will have centripetal acceleration. So tangential will be zero, but you'll have centripetal acceleration. So if you have acceleration, then why are you taking torque about A? Won't you have to apply pseudo force? Yes, you have to apply pseudo force, but something interesting happens. If you go and stand at A, this pseudo force will pass through center of mass, isn't it? Since the centripetal acceleration is passing through center of mass, the pseudo force will also pass through center of mass. So torque due to that pseudo force will be always zero. Now, at a mains level, you really don't care, but you should know that, small details. These are the kind of questions they can ask in advance by more than one choice questions. You can take torque about it, the answer will come, right? Not because you ignored the pseudo force. The pseudo force passes through the center of mass, that's why you ignored it. So you will take torque about it, that's one of the safest point. And then you have F into 2R is equal to I alpha. It's a 2 by 5 mr square plus mr square, parallax theorem. Alpha. From here you'll get alpha, you'll get A is equal to R alpha, and then you'll get F minus F is equal to MA. From here you'll get the friction. Once you got that, you say F is less than equal to mu n, then you'll get mu greater than equal to this thing. You'll get all the answers. Clear with that? I will leave that steps to you. And what about the second thing? Find H if F is zero. That I think is the easiest one there. This is F. So if F is zero, If you take torque about this point, meaning you're directly getting it in one step actually. F into 2r is equal to 7 by 5 mr square alpha. F is equal to ma. Take that and substitute there. This will be 2 mar 7 by 5 mr square alpha. Then A is equal to R alpha. This guy, this guy. Okay, wait, I have to apply H, na? My mistake. This is F is into H plus R. F is equal to MA. That would be substitute there. That would be MA H plus R 7 by 5 MA. And I think you get H is equal to 2R by 5. And they can even ask you the direction of frictions if you remember. That means if you apply friction, if H is greater than 2R by 5, you will have more rotation. So friction will be this way. If H is less than 2R by 5, the body will have more translation. Means if you move closer to the center, rotation will be less, the friction will be backward. So friction ka direction depends on at what height you are applying the force. So there's a particular point 2RF by 5. At that point, friction is 0. So even if you apply an infinite force, the sphere will never slip. All clear with this? Same thing. These questions, na, you can also ask in another way. Let's say we have a solid sphere where the upper half of the cylinder is positive, the lower half of the cylinder is negative. Let's say plus q, minus q. Hope you guys remember this. Mass m, radius r. No slipping. Then you suddenly switched on an electric field E in this thing. I can ask you a lot of things, find omega as function of the angle rotated and all that stuff. Find acceleration of center of mass. Same question I can ask in another way. So this is an N loops current wire. Current is equal to Y. And someone switched on a horizontal magnetic field P. Mass m, radius are solid sphere. Same thing I can ask you. Find the acceleration of center of mass. If it is an advanced question, I would have asked you find the angular velocity of the cylinder as function of time t. You can ask even more, but let's get these two. Electrostatics, magnetism. Let's see. So what are the catch in these kind of questions? So there are ways to do this. You can replace this entire charge at the center of mass. So hope you remember that, right? So you can replace this with the center of mass. So you should know the solid spherical center of mass, which is 3r/8. So this you can replace at plus q, and you can replace at minus q, and this is 3r/8. So for simplicity, what you can do, you can actually replace this with a dipole. So you can simply say this is like a dipole p bar, which is equal to charge into distance between them, which is 3r/4. So we get torque is equal to p cross e. So let's say after it rotates, this is the scenario there. P, this is theta, right? So we can, I will take the vertical as theta, and this will be 90 minus theta. So we will get torque is equal to P cross E. In this scenario, it is PE sine 90 minus theta, which is PE cos theta. And remember, torque due to a couple is independent of axis of rotation. I'm drawing this scenario. Okay, I'm doing it after theta actually. Or you don't like all that dipole thing, you can just treat it like this: plus q minus q. You get the same story. This is q into v. This is q into v. This distance was 3r/4, and this angle was theta, and this was your friction. And you're taking torque about A. So torque about A will be, that will be QE 3r/4 cos theta is equal to I about A into alpha. A is equal to R alpha. You'll get it in one step. So once you got alpha here, that will be QE 3r/4. Won't have finished about that is 7/5 mr square cos theta. You can write alpha as omega d omega by d theta, and you can integrate. You'll get omega as function of theta. And this thing will do what kind of motion? Oscillatory motion. This will do 1/4 of a revolution. Then you'll get maximum speed at the mean position. That means when the dipole becomes horizontal, then it will go in the opposite direction, decelerates, and then comes back again. So this ball is rotating forward and backward, forward and backward. Able to visualize that? So this will just keep on going front and back forever. It's an oscillatory motion. So you can ask a lot of stuff like that, maximum energy gained by the system and all that thing. So here also the story is the same. So here when it is rotating, you have your magnetic moment, which is mu bar, which is equal to NIA. Hope you remember. And this is your B bar. So torque magnetic is equal to mu cross B. Hope you guys remember that. Again, same story. You'll take torque about the bottom because the torque due to a couple does not depend on your axis of rotation. So torque about A will be, this in this case is mu B is equal to IA beta alpha. So you'll get alpha from here, you'll get A is equal to R alpha. Meaning you'll get this in two steps actually. If you take torque about the bottommost point, you'll get the answer immediately. If they ask you as function of theta, you have to put some work. All clear with this? Similar type of question. Let's say we have a ring, mass m, radius r. This guy is carrying current I. It is going from the right side, and then it is coming out from this side. Getting it? It's going in. It's coming out from the left side because different people see it differently. And we also have two ropes which are tied to the end. This is also standard model. If you remember, we have done this. And this is asked in mains also. And then someone suddenly switched off a magnetic field B, and the gravity is also present. This guy was T2 and this guy was T1. Find T1, T2 in equilibrium. I hope you're getting a ring is hanging horizontally. Along the diameter, you connected two ropes. Current I is flowing, N turns. Mass M, radius R. There is a magnetic field horizontally and a vertical gravitational field. Find T1, T2 in equilibrium. how to do this thing. So let's draw the free body diagram. What are the forces? T2, T1, your own weight mg. Here we have mu bar in the vertical direction. It's going in. So this is your b bar. It's important the directions. And what is the rotation? The torque. The torque is actually into the plane. Okay. So torque is mu b minus k cap. This is the magnetic torque. Right. So, and for convenience, you can take torque about any point. I will take about the center. Even you can take about the midpoint, doesn't matter. So when you take torque about center of mass, let's see the directions. T1 ka torque will be T1 into R k cap minus k cap. Magnetic torque is mu b minus k cap. Mg ka torque will be 0 and T2 ka torque will be T2R plus k cap is equal to 0. So this will give you one equation. T2 minus T1 is equal to mu b by R. And we also know T2 plus T1 is equal to mg. Two equations, two unknowns, so you'll get T1, T2. This was actual JEE Mains question. Clear with this? And the direction matters, because if you take torque in the other direction, T1 would become greater than T2. So plus and minus you have to be careful there. Let's get this one. This is a good one. We have a sphere, not a sphere, some body, moved of inertia I, mass m and r, height h, no slipping. Find the time to reach the ground. There are multiple questions kept in this. If it is a solid sphere, ring, hollow sphere, disk, case 1, no slipping. Case 2, slipping due to insufficient friction. Arrange them in descending order of time. Standard model. If you have two spheres, MR and 8M and 2R, who reaches first? We have done all these things in the class. But again, a standard model question. Let's get them. Now, this question, you should be able to do it in less than a minute. Because it's a thing, it's a standard thing. I told you in the class notes also, we kept a star for this. That's what I'm saying. Standard models, itna, frankly speaking, it's like you're itna, rata maar rahe ho, right? You should know the moment you see the question, you should know what to do. And if you remember the result, it is great. Then physics paper, you can wrap up in like 50, 55 minutes in mains, even 50, 55 minutes. But normally I would strongly suggest, some of you are doing this big blunder. Huh? You guys are finishing off physics and chem in 1.5 hours and you're doing max 1.5 hours. You should stop doing that. Even if you have additional time, please try to finish your max paper in 1 hour 15 minutes maximum. Let's say you finished your chemistry paper in 30 minutes. Just giving a random example. Physics paper you finished in 45 minutes, right? So the whole paper got over in 1 hour 15. So you have 1 hour 45 minutes for max. You should not be doing 1 hour 45 minutes for max. You should do it only for 1 hour 15 minutes max, and half an hour is gone. If you are taking more than 1 hour 15 minutes for max, meaning your subject is bad. Instead of focusing on the subject, you're just increasing the time. What will you do in the exam if the physics paper comes tough and you can't solve the physics paper in 50 minutes, but take 60 minutes? And what will you do if the chemistry paper there is more mole concept and more of this acids and bases and calculations, and the paper takes 50 minutes? Think about this. Chemistry paper taking 50 minutes. Do you think it is impossible? Is there a chance chemistry paper can take 50 minutes? Is there a chance physics paper will take 60 minutes? And ye hua tha. This thing, I'm not joking. This thing happened. This thing happened every year in 1 or 2 papers. This thing happens. The paper is not lengthy. You see the physics paper, everyone will say, I know every question, but I need 1 hour to solve. The problem, what happened, there are people who are doing these old PYQ papers, previous year papers. Now they got an illusion, 1.5 hour mein physics, chemistry khatam kar lenge, 1.5 hour max karenge. Unfortunately, on that day, you don't have time. You have only 1 hour 10 minutes for max. Even then, you can still do it. But the problem, first thing, you start panicking. Oh shit, I don't have time for max. And in that panic, you'll mess up even more. So take this suggestion from me. I'm strongly telling you, you should not do max paper more than 1 hour 15 minutes. If you're exceeding that, meaning your subject is so bad, you instead of spending time in learning and improving your subject, you are just finding loopholes somehow to survive. Maybe you will survive luckily in one mains, you will get slotted in mains, bits exam and advanced exam for sure. So please don't take that risk. If you're taking more than 1 hour 15 minutes, your subject is not strong. So work on that instead of increasing more and more time. So keep this in mind. Next time when you write a paper, max should not take more than 1 hour 15 minutes. After 1 hour 15 minutes, you still have 20 minutes left. Just shut down the damn exam and you're done. Be ruthless with that. You can finish your physics paper early, great. You can finish your chemistry paper early, great. But doing max paper for 1.5 hours is a disaster. Sir, but paper is so tough, paper is so lengthy, still a disaster. Huh, in the final exam it happens, then you spend, na? That's a good thing. But don't do that in practice, isn't it? It's like, you know what? Imagine, you know, let's say tomorrow you're starting a big project or something, okay? And you're starting the project with an assumption you brought a lottery ticket, or lottery ticket में 10 crore मिलेगा, so I will invest that in the company. That is a business plan. What do you guys think? We will say, we are going to hire 20 workers, we are going to put a big business setup, we are going to spend that, this, everything. Total cost is 10 CR. And someone asks, okay, where are you going to get the funding from? Can you see the lottery ticket in my hand? So this thing, results are coming out in a week, and we will know what happens there. And then with the 10 crore, we'll start the business. So thinking, max के लिए 1.5 hour मिलेगा and the exam is a lottery ticket. If you got it, great. But don't go with that assumption. Assume you'll get 1 hour 10 minutes for max paper and go with the plan. So how do we do this? Let's see. Meaning, I know the results. First result, what is this thing? If you remember the acceleration, A is equal to G sine theta by I by mr square plus 1. Bas, matlab, if you don't remember this, you have to solve. Once you know this, you're done. S is equal to ut plus half at square. This is h by sine theta. The incline initial speed is 0. This is half at square. From there, you'll get the time. Root over 2h by a sine theta. And you can clearly see whoever has more moment of inertia will have least acceleration. So it takes more time to go this thing. So more I, more time. Then even he can ask you, and this also implies less speed. They can ask this question also: who reaches the ground with the least speed? So who has the biggest amount of inertia? The ring. So time taken by the ring is the greatest. Then comes your hollow sphere. Then comes your disk or solid cylinder. Both are same. And then comes your solid sphere. That was your first question, right? First and second thing. And what happens if they all slip? If they're slipping, the friction is maximum. Then your acceleration becomes g sine theta minus mu g cos theta, which is same for all. Independent of the shape of the body, they will all have the same acceleration. Therefore, time is same. All will reach at the same time. What about this thing? Again, same story for this thing. If you see the formula for acceleration g by g sine theta, numerator is same for both of them. Moment of inertia by mr square plus 1. It doesn't matter what sphere you take there. Solid sphere, it is 2 by 5 mr square. You'll get 2 by 5 plus 1. So they will take same time. It only depends on the shape of the body. Clear with this. That I by mr square ka term will be always 2 by 5. Clear with this? Take a 5 minute break. Come back in 5 minutes. We'll continue from here. Chalo, let's get these two. Solid cylinder on a plank, same mass, radius r, ground is smooth, there is friction between them. Find the acceleration of the plank and the acceleration of the cylinder. Second thing, square plate hinged at one end. If both are strings, that would be a much better question, but that would be advanced level only. So let's keep it simple. Acceleration center of mass, find the hinge reaction just after cutting. Still a good one though, for a mains one. So rotation, right? Even though it feels like, oh, it's a big chapter and all, at a mains level, you actually see there is nothing much. You should know moment of inertia. You should know how to calculate torque. You should know your rolling motion, energy, and then angular momentum conservation standard problems. Not even that big, collision, impulse and all. They won't ask generally at a mains level. And we will anyway do that stuff again in advanced revision. Again, when you do advanced revision, again we'll do for all the chapters the same we did for mains. We'll do it for advanced also. We will again do maybe every two chapters. We'll keep doing. Mostly that we will start somewhere in March first week or something. Let's see the first one. Step 1, draw the FBDs. Even this is not a mains level question. This is F. This is friction. This is friction. Right? I'm not writing vertical forces. This is A. This is alpha. And this is AP. Now, what is no slipping condition here? A minus R alpha, that is the bottommost point of the sphere, must be equal to AP. This is the no slipping condition. Be careful. Don't write A is equal to R alpha blindly every time. And then force equation, F minus F is equal to MAP. And now you can take torque about A. Torque about A is not preferable because it is accelerating horizontally also. You have to apply pseudo force. So even previously it was accelerating, but luckily the centripetal acceleration was towards the center of mass, since it has horizontal acceleration. So keep that in mind. Don't take blindly. The reason I gave you this question is for that sake only. Because blindly now you will think I can take torque about the bottommost point every time. You can't do that if you're having a horizontal acceleration. That's it. That is the whole purpose of this question. It has horizontal acceleration. Don't do that. If you are sure that point has no horizontal acceleration, you can do it. Then what will you do? Center of mass. Torque about center of mass is always the safest point. That will be F into R. Now here, see, be careful with the sign. I did a small goof up there. I took F this way, but alpha is this way. So you have to be careful with the signs. Fr is equal to I into minus alpha. Clear? But if you say, okay, I will take alpha this way, no problem. Then this will be plus, but then this will be A plus R alpha. Are you getting it? The sign will change somewhere. So you have to be careful with the signs, how you're taking. So this is your third equation. Three equations, three unknowns, so you'll get all the answers. Clear this? What about this guy? Find A center of mass, hinge and all. So if you cut this, Nx, Ny, Mg, alpha, your center of mass is going in a circle. So your A center of mass will be L by root 2 alpha. This would be AX and this would be AY, which is AX will be A cos 45 and AY will be A sin 45. Torque about the hinge, which will be mg L by 2. Moment of inertia of a square plate about the corner is 2 by 3 ml square alpha. Mg minus Nx is equal to MAY. Ny is equal to MAX. AX is equal to AY is equal to, because it's a square plate, okay? Center of mass cos 45. So you'll get the answer. Is it clear, everyone? Before going ahead, let me ask you one more. So we have a carpet. You can treat like a solid cylinder. Tightly wrapped carpet. Radius R, mass M. Then the carpet started rolling. The radius became R by 2. V and omega. Find V and omega when the carpet ka radius becomes R by 2. Is angular momentum conserved in this system? Are you getting the question? We have a carpet there and you just slightly disturbed and the carpet started rolling on the floor. Find the speed and the omega when the carpet ka radius becomes R by 2. And in this system is the angular momentum conserved. If it is not conserved, why? If it is conserved, why? First get the first part, then we'll talk about angular momentum. Let's see the energy part. So what's happening there? Look at the center of mass. Initially, your center of mass is at R. So your potential energy, this is your center of mass. This is the center of mass. So loss in potential energy is gain in kinetic energy. So mgr. What happens to the mass? If the radius is r by 2, mass becomes m by 4. M by 4, gr by 2. It's a solid cylinder, right? So it depends on the area. Plus half mv square, but m has become m by 4 v square. Half I omega square. It's a solid cylinder. So it's mr square by 2, but m became m by 4. R became r by 2 omega square. Please check that equation. The loss in gravitational potential energy is equal to rotational kinetic energy plus translational kinetic energy. And mass of the r by 2 cylinder is m by 4. It's not the same mass. And the biggest mistake people do is this. What is no slipping condition? The no slipping condition at the smallest point here, this is v, and this thing radius became r by 2. So the no slipping condition is v is equal to r omega by 2. Clear with that. V is not equal to r omega. Meaning, yeah, v is equal to r omega, but the r was radius, which is r by 2, isn't it? So be careful about the no slipping condition. I have seen people doing blunders on that. Not because you don't know. In a flow, right? What is no slipping condition? A is equal to r alpha. What is no slipping condition? V is equal to r omega. That should not come out of your mouth. Right? Whenever you see a question and you tell yourself, okay, what is no slipping condition? You know it is on the ground. Okay. Then you say, what is no slipping condition? The point of contact should have no relative velocity. Okay. Since it is on the ground is 0. So therefore V is equal to r omega. You should make that statement to yourself. That will give you a pause. Next time when you see a question, right, your brain will understand, okay, there could be a problem here. This is not ground. But every time you, just for the sake of speed, if you say V is equal to r omega, you will get trapped. I did this mistake. So be careful. I just took V is equal to r omega and I goofed up the whole thing. And the answer is there. That is the worst part. If that answer is not there, at least you'll go back and check what went wrong. And if that option is there, you won't even think twice. And then, yeah, you're done. What about angular momentum? Is it conserved or not? That's a good question. Now, to conserve angular momentum, torque should be 0. So if you look at the forces here of this carpet, what are the forces? The friction, the normal reaction, and mg. So if you take any point about here, n is equal to mg and friction is passing through A, so is torque about A 0 or not? N is equal to mg and friction is passing through A, so therefore torque about A is 0, therefore angular momentum about A is conserved. What do you guys think? Listen to my explanation. F is passing through the axis, n is equal to mg, therefore the total torque about A is 0, therefore angular momentum is conserved. This is what I'm saying. And this is a blunder. Tell me why. Not a blunder, this is wrong. This is not right. Arey Aditya, it is touching at one single point. N kahan pe shift hoga, God? It's a cylinder, right? On a floor. We are not taking the whole carpet. We are just taking this chota sphere, na? That the carpet on the floor. I don't care about that. That is anyway at rest, isn't it? What do you guys think is the mistake is? N is not equal to mg. That was a mistake. Why? Mg minus n is mass into acceleration of center of mass. Center of mass is moving downward, na? Think about this. Where is the center of mass initially? R. Now where is the center of mass? R by 2. Center of mass is moving downward. Therefore, torque about A is not a 0. In normal cases, what used to happen? N is used to be equal to mg. Now n is not equal to mg here because it is shifting down. Therefore, angular momentum about A is not conserved. Clear with this? Because we have a habit, right? N is mg. But what we forget here is the center mass of this thing is continuously coming down. So the center mass is not at rest. All clear with this? It's a good one. Let's get these three equations. Hope you guys remember the net torque method. You guys remember I taught you something called a net torque method. Replace the blocks with point masses at the point where the string touches the pulley. That is this point. You can replace the masses and finish it off. Only problem with the method, it is valid only for one single pulley. Yeah, two pulleys, you can't do it. Let's get this. and others do keep your cams on. Let's see. Again, shouldn't take much time if you actually remember this thing. So what you do, replace the blocks here, 2m and m. Assume alpha is this way. So this is 2mg and this is mg. So if you take torque about the center, the 2mg is supporting alpha 2mgr and mg is supporting this thing r is equal to I of the system into alpha. What is I of the system? You got a disk which is mr square by 2 and we have two particles which is mr square and 2mr square. Same story here, replace this with a mass here. This is mg, so alpha will be mg into r. By total moment of inertia, we have a disk plus that particle. So you are actually treating that particle as part of this. You always take torque about the center of mass. So the pulley ka weight will not create any torque about that. Same story here, replace with two particles, m2 and m1, and then we will get alpha is equal to same story, m2 gr2 minus m1 gr1 by the moment of finish of that thing will be I plus m1 r1 square and m2 r2 square. Clear with this? And once you got alpha there, then remember accelerations will be different though. A1 is equal to r1 alpha and a2 is equal to r2 alpha. All clear with this? Let's get these two. We again, I'm not asking you to find the acceleration, but I'm just want you to find v and omega of the cylinder. So we have a cylinder there, mass and radius r. This is a string wrapped around the cylinder and tied to the plank. The this the plank is going with Vp. Find v and omega. We have a disk going with v and omega. Find the speed of point A and how many points on the disk have speed v. Let's see. So if you just want V and omega here, let this be going with V and let this be omega. So this point is going backward with R omega minus V. This point is going forward with V plus R omega. This point is going with VP, and remember this point is also going with VP. So we get R omega, so the minus V. So I'm talking about this thing, the string constraint must be equal to VP. So velocity along the string must be same. So there's a string constraint and there is also a no slipping condition. And the bottommost point, it's not slipping. So that is V plus R omega is equal to VP. This is your no slipping condition because the bottom point is in contact. When you add them, interestingly, you will get V is equal to 0 and you get VP is equal to R omega. That means this cylinder here is not going at all. It is at the same place and simply rotating. You're getting the cylinder is simply rotating without going front or back and done. And what about this thing? IAR. If you remember, we have done this before. Go stand on the IAR. The bottommost point is the IAR. So all you want is this distance of the black line. That's 30. So this is 120. So drop a bisector. This will become R root 3. Yeah. Then speed of A will be R root 3 omega. How many points are there? Infinity. If you stand on IAR, all the points at a distance R, they will lie on a circle. All these points will have a speed V is equal to R omega. V. There are infinite points with a speed V. If it is a ring, then the answer would have been 2. Why R omega minus V is negative P? They should go in the same direction, God. This is pushing this way. The string is also getting tight here. No? The string released by the upper part must be equal to the string gone from the bottom part. Whatever the string is becoming loose, this should make it tight, na? Velocity along the string. So be careful with that. If you have taken that as omega in that direction, na, then what you said was right. P plus R omega would have been minus VP. So be careful. I took omega in the reverse direction. I didn't take your standard omega. I took omega backward. You could have chosen anything. Let's get this thing. This is another good one. We have a hollow shell, mass and radius are high touch, no slipping. Find V when it reaches ground. Find the ratio of translation and rotation kinetic energy. If it is filled with non-viscous liquid and mass m, then find speed when it reaches ground. If it is frozen to ice, then find the speed. 4 questions. Mm, finish off, finish off. I'll give another 2 minutes for all four of them. Let's see. So find the speed when it reaches the ground. That is easy, and that was a mains question, huh? That was a mains question. They do ask. So loss in potential energy, mgh is equal to half mv square. It's a hollow shell, so half I omega square, ICOM omega square, that is half 2 by 3 mr square omega square. The bottom is a ground, so it is not moving, so I can use V is equal to R omega. So you'll get the answer. Want the ratio of kinetic energy of translation by rotation? This is also a very standard question. I saw this thing in CET or somebody must have noticed that. So what is translation here? Half mv square by 1 by 2 by 3 mr square omega square. M goes off, V square goes off. You will end up with 1 by 2 by 1 by 3, 3 is to 2 ratio. You know, where did you see this kind of questions? Thermodynamics. Find the ratio of translation and rotational kinetic energy in a diatomic molecule. Yeah, there is a question. So 3 is to 2 degrees of freedom and stuff. So, and what happens if you have water? If you have water, non-viscous liquid, then there'll be no rotation inside. The liquid will simply translate. Then your equation becomes M plus small mgh, the total potential energy, half mv square, half ICOM omega square. This is for the shell. Be careful, you cannot treat the whole thing as a solid sphere. It's a non-uniform then. This will be half mv square. This is for the liquid shell. There'll be only translation. When it is frozen to ice, now that ice ball also will start rotating. This will be m plus mgh is equal to this will be half mv square plus half 2 by 5. It's a solid sphere. R square omega square. Is that clear, everyone? The energy mgr should be there or not? Mgr. Nee, na. See, we are taking height from the, let's say, base. You're interested in the difference in height, na? So when it comes to the ground, this is also always at a height r. Right, Devant? So it depends on where you're taking the reference line. I'm giving you h from the base, not from the center. So if you take from the center, that will be h plus r. When you come to the ground, it will be r. So that r will always get cancelled. Clear? So what you're interested in is loss in potential energy. You actually don't care about the exact height. Let's get these three. We have a solid cylinder. Again, if I don't say anything, take always h from the bottom, okay? We have a solid cylinder. So left side is no slipping, rough, and the right side it is smooth. You left it from height h. What is the maximum height it will reach on the smooth surface? Rod of mass m, L, released from the horizontal position, find the hinge reaction at the lowest position. Solid sphere rotating without no slipping, find the kinetic energy of the upper hemisphere. Let's see. So what is the catch in this question? Catch in this question, when this guy comes at the bottom, you'll have V and omega. But as you're climbing on this, if you notice, there is no friction anywhere. And mg is passing through the center. N is also passing through the center, and friction is 0. So torque is 0, therefore alpha is 0. If alpha is 0, that means no one can change your omega. Omega remains same. So at the highest point, your velocity will be 0, but you still have that same omega which you had at the lowest position. So this is my state 1, this is my state 2, this is my state 3. So energy in state 1, loss in potential energy will be mgh is equal to half mv square plus half I omega square. This is between 1 and 2. Then you do between 2 and 3. Half mv square, half I omega square. You can actually argue like this. Only the translation energy becomes the potential energy. This guy will become mg h dash, the new height, plus half I omega square. This goes off. So h dash will be root over v square by 2g. And you can get v from here. Take that and substitute the answer. What about this? When the rod becomes vertical, this will have omega. Loss in potential energy, mg L by 2 is equal to gain in kinetic energy. It's a pure rotation about the hinge. So half I hinge omega square, which is ml square by 3 omega. What are the forces? Ny, nx, mg. Since you're going in a circle, there's also centrifugal force, m omega square L by 2. Nx will be 0 because there's no other horizontal force, and ny will be mg plus m omega square L by 2. This last one is a pretty good one. That could be even an advanced question. What is the kinetic energy of a solid sphere? Now, this thing is a translation plus rotation, so I can use the formula, one translation, one rotation. Kinetic energy of the system is kinetic energy of center of mass plus kinetic energy about center of mass. Remember, this is only valid when you have a translation plus rotation. At a mains level, it works. Advanced may they will play around with more. They'll give rotation plus rotation and stuff. We will see later on. So for the upper hemisphere, if you just look at the upper hemisphere, where is the center of mass for upper hemisphere? Here, 3r by 8. That means this guy is going with v plus 3r omega by 8. This is your vcom, v center of mass. And what about I moment of inertia about the center of mass? Okay, so this formula will be half m by 2. Remember, the mass has become half because you're only taking for half of the hemisphere. V plus 3r omega by 8 whole square plus half I center of mass omega square. It's a lengthy one. And I center of mass we have to calculate. Now, unfortunately, I know about this axis, but this is not the center of mass. How much is this? Solid sphere passing through this, it will be 2 by 5. Mass has become m by 2 r square. Clear with that? A hollow solid hemisphere or a full sphere, if the mass is same, moment of inertia will be same. You want I center of mass, so IO will be I center of mass plus m by 2. The distance will be 3r by 8 whole square. That from here you get I center of mass. Take that and put it here. You will get a lengthy one. But if they ask you kinetic energy of the lower hemisphere, then the only difference will be this will be v minus 3r omega by 8. The rotational component will be same. If you add the whole thing, you will get the regular kinetic energy. Is that clear, everyone? So be careful. Huh? You just can't say half of the total energy. The upper hemisphere actually has more energy compared to the lower hemisphere. Do you agree with that? The points in the upper hemisphere travel faster than the points in the lower hemisphere. So upper and the lower hemisphere don't have same kinetic energy. I can even ask you the ratio also. But this question, once you got that idea, it is calculation based. Conceptually, you can handle. Next thing, a 2 kg particle moves along 3x plus 4y plus 1 with 10 meter per second. Find angular momentum about 1 comma 2. Particle is projected with u theta. Find L bar about the origin at time t. We have a disk rolling on a floor with v and omega. Find angular momentum at point A. The angular momentum questions, you should know how to calculate angular momentum first. Biggest drawback people have is they have a problem calculating angular momentum. At a means level, you should know angular momentum calculation and conservation standard problems. They will not even ask you impulse, collision, all that stuff will be pretty rare at a mains level. Let's get them. Finish. I'll give you a minute more. Let's say. What is angular momentum? M R perpendicular V. Remember? There is a question like this. Huh? Most people googled it up. They said there is a particle which is traveling along this line. It's going from infinity to 1. So the question was this: what happens to the angular momentum? And there are 4 options. Angular momentum always increases, decreases, increases and decreases, decreases and increases. What is the option? About the origin. A particle is going in a straight line from plus infinity to minus infinity. So when you drop a perpendicular, it doesn't matter how far you are. The most common mistake is this. Sir, initially distance is decreasing, 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 and then increasing. So angular momentum must decrease and increase. Blunder. Angular momentum is mr perpendicular v. The perpendicular distance remains constant. Answer is constant. Clear. Simple question, but for some reason we think it will decrease and increase. So how do you find the perpendicular distance? You know how to find the perpendicular distance from a line. Perpendicular distance will be ax naught plus by naught plus c by root over a square plus b square. Use that formula, finish it off, you'll get the answer. What is the angular momentum about the origin? Again, same story, mr cross v. There are two ways to do this. You know r bar and v bar, you can do that. I think we have done this before, right? You can do that, find r bar, v bar and finish it off, or there's a better way. You can find angular momentum delta L bar is equal to torque dt. Kinematics में किया था ये. This is mg and this was u cos theta t. mg u cos theta dt minus k cap 0 to t. Integrate this, you'll get the answer for that. What about this thing? Angular momentum of a rolling body is angular momentum of center of mass, in case you forgot. Angular momentum of center of mass, meaning you treat center of mass like a particle, then go and stand on center of mass, and angular momentum about center of mass. This is for a rolling body. Means you treat the center of mass like a particle, m r c o m cross v c o m. Then go and stand on center of mass, I alpha c m omega. So in our question, extend the line velocity, drop the perpendicular. This will be mbr minus k cap. If you go and stand on the center of mass, you will see ICOM, which is mr square by 2 omega. Rotation is plus k cap. Be careful with the signs. Plus k minus k cap is important. If you just blindly wrote the magnitudes, you will mess up. They'll not add up every time. That's the reason I made omega reverse. Clear with this? Let's get these two. Another standard questions. Solid sphere M and R suddenly became R by 3, same mass, find new omega. We have a disk of M and R, another disk of R by 2, same thickness is placed on it, find new omega. These all are standard angular momentum based questions. Let's see. I1 omega 1 is equal to I2 omega. So omega final will be 9 omega here. What about this thing? There's nothing much. Idea is the same, but people go for this. This mass is m by 4. That is the main go up. So initial angular momentum will be mr square by 2 omega. This will be mr square by 2 plus that small disk mass became m by 4 r by 2 whole square by 2 ka omega dash. Clear with this. You'll get it from there. Right? On based on this, people have theoretical questions. If all the ice from the poles melt, what happens to the time period of one rotation of Earth? Or what happens to the duration of the day? Increase, decrease, remain same. Did you get the question? If all the ice at the poles melt, what happens to the duration of the day? One rotation, how much time will it take? More or less? They do ask, huh? They do ask this kind of questions. If all the ice melts at the poles, understand one thing. Initially, all the mass is concentrated near the axis. So as the mass shifts, moment of inertia increases. I increases, omega decreases. So Earth will rotate slower. So duration more, it will be more than 24 hours. Clear. If you take a boiled egg and a raw egg, and if you rotate them, a boiled egg and a raw egg, and if you rotate them, what happens to the omega once you start rotating? Will they increase or decrease or remain same? If you're a Jain and you have no idea about the egg, I'm sorry. You have to figure it out. In a raw egg, everything becomes solidified. So nothing moves. So omega remains same. In case of a raw egg, the yolk, which is the middle part, denser part, it's like your earth ka crust and the core. Because of centrifugal force, this will shift to the edge. So your moment of inertia has increased. Think of like this: when you switch on your washing machine, all the clothes go to the edges and the water remains, foam remains in the center. So whenever you switch on your washing machine, moment of inertia of the washing machine increases. Getting it? So the egg, the raw egg moment of inertia increases. So actually the egg slows down once you start rotating it. Let's finish all this. Solid sphere, you have thrown it with speed v and omega 0. This is what you do with a bowling ball. Find v final, omega final, and the time when the slipping stops. Raw egg, it has two different materials inside, right? It's not completely filled with same liquid, right? In a raw egg, you have a yolk, which is the densest part, and then you have a surrounding fluid, which is less denser. So when you rotate any system like that, the denser parts will always go away from the axis, and the lighter part will get towards the axis. The moment of inertia gets messed up. So how do you do this thing? This is a pretty important question. You should definitely check it out in case you don't know how to do this. So when this guy is rolling, if you look at the forces, we have friction backward. N and mg here, n will be mg because center mass is not going up and down. If you take torque about any point on the ground, right, it will be torque about A is 0 because friction passes through this. Eventually, this will get some speed v final, omega final. And then angular momentum L about A is constant. Initially, there is no omega. So angular momentum will be mvr minus k cap, and this will be mv final r minus k cap, and it's a solid sphere, the 2 by 5 mr square omega, that is I omega minus k cap. Since it's not slipping, eventually Vf is equal to r omega. So substitute there. From there, you'll get your V final. And then we can use kinematics. V final is equal to U plus AT. And here acceleration will be minus mu g because you're decelerating at F is maximum. So we get V final is equal to U initial minus mu gt. From there, you get the time. Clear with this? I can even ask you find the distance traveled, before it stopped slipping. All that stuff you can ask. You can play around more. But it's a very good question. Meaning, I can even ask what if it is an omega and all. But check it out. We did 2-3 models on this. Okay, take a break. We'll wrap up with this. Have your dinner. We will start the exam at 9:05, the speed test. So any doubts in the class notes, anything you can ask, or else you can switch off, go take a break and come back by 9:05. You can log in with the same, that link. I won't be sending it again. So just join by 9 o'clock and we'll start at 9:05.